So, as I've already told you, it's definitely going to part two of corneal physiology in relation to contact lens. Definitely in relation to contact lens. So we have discussed a lot about decay, decavity, and their relation, and EOP, oxygen flux. Now let's come to lens performance criteria for maintaining corneal health. So basically, till now, Holden and Merz criteria we take seriously for clinical consideration. Okay, so according to Holden and Merz criteria, and just remember, it's like 100% in every contact lens MCQ questions in every examination. It's like 100%. Yeah, it's definitely 100% overestimation, but it's 99.99%. Okay, so chances that there is question like what is the Holden's criteria for daily wear, what is Holden's criteria for extended wear, what is Holden's criteria for daily wear in EOP. So Holden's criteria for daily wear, so DK by T must be 24. So remember 10 to the power minus 9 is DK by T, yes, it's 24, and EOP is 9.9 for daily wear. Just remember these two things, 24 and 9.9% EOP for daily wear, at least to have uh, cornea. We have healthy cornea, that oxygen is not deprived so much that it creates havoc there. Okay, so for extended wear, digavity is 87, and 17.9% EOP is required for at least lens use overnight swelling is 4%, because 4% is normal overnight swelling, isn't it? When you sleep every day, there is a chance of overnight swelling of cornea is approximately 34%. So that's held Holden Merz criteria 1984. It is very famous criteria till now. Okay, so this is recent criteria, which is Harvard and Bonanno criteria. So many times MCQs come like according to Harvard and Bonanno criteria. Then just don't forget at that particular point. It's not about Harvard Holdenworth criteria. Okay, Harvard and Bonanno criteria is a different criteria. So what Harvard and Bonanno actually trying to do is to prevent anoxia across the entire thickness of corneal thickness. And what Holdenberg said, yes, there is 4% of edema. It's completely okay. But here, Harvard and Bonanno try to prevent anoxia across entire corneal thickness. Okay, so for that open eye conditions, 35 is decavity needed, and for close eye condition, 125 decavity needed, and 125 with any hydrogen lens. Is it possible? Impossible. So no chance. Okay, a number of other authors suggested that the criteria decavity required to maintain normal physiology should be raised upward up to 125 degrees. So Harvard and Banana attempts to correct the corneal acidosis effect and suggested to prevent. So similarly, Sweeney et al. And Papas also attempted to revise Hodenworth's criteria and remarkably arrived at the same revised around value of 125. So just remember Harvard and Bonanno criteria for daily wear it's 35, and for extended wear it's 125. Okay, it's not extended wear but actually closed eye lens wear 125. They have not specifically said extended wear, because by definition extended wear means 7 days 6 nights. So we have already discussed about it. Yes, corneal transparency, theory of corneal transparency, stromal arrangement like Morris theory and Goldman theory. So we have already discussed. So I should skip, and we have already discussed that corneal hydration. So we know it's approximately 78%, and cornea is allowed to swell approximately 5% value, because we every day it's swell around 3 to 4%. But it's definitely one of the factors that we know is stromal swelling, pressure, and IOP, variable function of epithelium, endothelium, hydration controlled by active pump mechanism, which is central important evaporation of corneal surface. So these five factors we have already discussed about. So we have already discussed about the endothelium pump mechanism. So effect of contact lens on metabolism. So I have already discussed. Let me discuss once more. So when we put contact lens, if contact lens material is bad, which means decay is very low, then contact lens restricts the oxygen availability. Then what happened? Then actually hypoxic environment at the anterior surface, basically, isn't it? If there is no oxygen, it means hypoxia, yes. And then reduce the aerobic glycolysis. What do you mean by aerobic glycolysis? It means actually Krebs cycles. So it's approximately 15% is in normal condition, but if there is no oxygen, then Krebs cycle reduces. Then what happened? Then all the stress goes to anaerobic glycolysis. So in case of anaerobic glycolysis, what is the product of byproduct of anaerobic glycolysis? Lactate. And lactate concentration increases in the stroma, definitely. Yes. And what happened when lactate concentration increases in the lactate is basically acidic shift, and concentration of lactate accumulate on the cornea. That's why osmotic imbalance is there. So what happens if there is on osmotic imbalance? To balance what osmotic imbalance secondary to lactate accumulation. So balance increase the movement of water into the stomach directly through most probably aqueous, isn't it? And then one thing is aqueous is compromised. So aqueous is drawn towards the stroma because of the osmotic imbalance. Another point is, yes, we know that aerobic um, Krebs cycle is not there, it's not functioning fully, then we do not have ATP as required. Then diminish of ATP slow down the endothelin pump mechanism. What do you mean by slow down in endothelin pump mechanism? One side there is a accumulation of water because of this uh, osmotic imbalance. Another side, the only possibility was best possibility that endothelial cells functions, that endothelial cells cannot push out this water. Then what happened? Water remains in the stroma, which means, isn't it corneal edema? Yes, that's the function, that's the pathway. So many of the times students will ask in 5 numbers or 10 numbers that basically pathway of why there is a stromal edema, or pathway of stromal edema, or pathophysiology of stromal edema. Then you have to write these 2 slides. Okay, it's very important. So basically what I'm telling is this: just pause the video and read. And definitely, whenever there is a reduction of what do you call it, oxygen, hypoxic condition, there are a lot of things changes in the cornea. So let's discuss one by one, and then I'll finish this presentation. First, corneal sensitivity. So cornea is the most densely innervated tissue. Yes, definitely. So innervation protected the eye by making highly sensitive and responsible to foreign bodies, abrasion, etc. So if for to maintain corneal sensitivity, minimum 8% of oxygen is required to maintain the corneal sensitivity. So um, they have suggested that. So below 8%, then definitely corneal sensitivity will lose corneal sensitivity. Okay. So sometimes they ask this question: what is the minimum amount of oxygen required to maintain corneal sensitivity? Just remember in MCQs. Okay. So changes in sensitivity due to the contact lens wear. First is cornea hyposthesia is the first effect of hypoxia. Then epithelial acetylcholine is decreased in hypoxia. So basically they found the reduced sensitivity 100% following the around 8 hours of PMMA use. So a 2 hours recovery period was observed before the corneal sensitivity. PMMA decayed 0. So it's very important to understand if you reduce the hypoxia, if you reduce the oxygen level at epithelial. So also reported the average loss of sensitivity 45% following 24-hour wear with low water content material. Basically low water content material means low decay, isn't it? At least for hydrogel contactants. So corneal acidosis means basically acidic pH lowers, isn't it? Stromal pH lowers during the contact lens wear. That's acidosis. So contact lens lowered pH may cause the corneal structure and functional change. Yes, definitely. It appears that lactic acid accumulation in the combination with carbon dioxide buildup is responsible for acidosis of the stroma and pres- presumably the epithelium. So basically means whenever there is a condition, hypoxic condition, so accumulation of the lactic acid is very simple, because anaerobic glycolysis goes up, and the byproduct of anaerobic glycolysis is lactic acid. So clinically reduced pH has been cited in responsible for transient morphological endothelial change such as blebs. So it is said blebs is a response of transient pH shift towards acidity. So yes, definitely bleb is a transient response, and we are definitely going to discuss about these small changes, especially small structural changes, more in depth when we are going to talk about it in uh, contact lens induced pathology, soft contact lens or hard contact lens in these sections. Okay, so corneal tissue fragility. There are a lot of points. Let's go one by one. Reduced epithelial adhesion due to the reduced number of hemidesmosomes. It happens when really severe level of reduction of oxygen, and then decrease in the level of metabolic activity including rate of cell mitosis. Yes, it's also there with hypoxia. Fewer cells are being shed off in the ocular surface. Yes, cells life increases, and those at the anterior surface of the epithelium may not retain normal function resistance. Yes, increased likelihood of microbial penetration and subsequent infection. It's always there whenever corneal tissue becomes fragile. The initial stage may be superficial punctate keratitis, which is followed to continue, especially long hours of contact lens wear may not allow adequate healing of period, and this will increase the risk of bacterial infection and susceptibility injury. So it's always there. The punctate keratitis, the cornea is exposed, then it's always risky for bacterial infection. It's always there. So corneal temperature. So it's very simple. We have already discussed it. The central cornea has temperature of 34 degree, which appears to increase towards the periphery if found nearly by 0. Why periphery? Periphery has blood vessels at limbus, so that's why periphery is a little bit warmer. The normal corneal temperature may alter during contact lens wear. Yes, usually cornea is cooler than body. Yes, body is around 37 degree, cornea is around 34 degree. But whenever you put the contact lens on, then corneal temperature goes a little bit up. So change in temperature may be only 3 degrees, but the rate of metabolic activity is so dependent on the ambient temperature that the fine balance between availability of oxygen and corneal demand under the closed eye may be stressed by such a small temperature. Basically means whenever you put the contact lens, chances are up to 3 degree increase in temperature of the cornea. So up roughly up to 2 to 3 degrees. Okay. So contact lens effect on tear film osmolarity is always there. So normal tear film osmolarity is around 300% milliosmol per liter, isn't it? So the initial hard lens were produced decrease in tear osmolarity brought about by reflex tearing, and reflex tear which are low tonic and may disrupt the fluid barrier and provoke. Basically means whenever you put something, there is reflex tearing, and because of reflex tearing, osmolarity goes down. But initial soft lens will increase the tear osmolarity, and this may be caused by change in the blink rate and causing the increased evaporation. So if there is great evaporation, the osmolarity went high. So that's basic concept with contact lens. Okay. So structural changes due to the hypoxia is very important. Structural changes, epithelium and stromal edema, it's very important. Microcystin bacules, it's very important. Stripe folds, endothelial breaks, endothelial polymers, and these are all important. But these are the topics which we are going to cover on under specifically contact lens pathology, isn't it? So let's discuss a little bit about it. Okay. So stromal edema, which is very central topic. The edema refers to increase in the fluid content in the tissue. Since the cornea is only able to swell anterior posterior direction as a result of the collagen fiber network in the stroma, physical dimensions of the cornea can alter, increasing in the dimensions, and that is the thickness. So in human experience, corneal edema during sleep is normal, which is 4%. Upon awakening morning, the cornea immediately begins to reduce the thickness. Basically means diswell. That 4% went to 0% immediately after awakening, and it around normal around 1 hour of awakening. So basically that the factor contributing to the corneal edema after sleeping reveals the hypoxia major cause. So one of the most important why cornea swells when we sleep is hypoxia. Okay, one of the major things. So all contact lens induce some level of edema, including extreme high oxygen permeability silicon elastomer. So elastomer is always in silicon elastomer. It's like DK like 300, isn't it? But all contact lens create some amount of edema. The magnitude of corneal edema is estimated by careful observation with the slit lamp biomicroscopy. The structural changes, striae, folds, haze, act as useful reference point from the basis of clinical decision making. It's always important. You cannot always make it like edema like 4% by seeing things. For clinical observation, it's very important. You see striae, folds, or even the smallest thing that I always use to find out is prominent corneal lobe. If there is edema, then corneal lobe becomes prominent. So that's also another point, another small trick that you can use on slit lamp. So striae is very simple. See, striae in the posterior side of this is endothelium, this is epithelium. Striae is always seen in the posterior stroma. Okay, so striae means white wispy fine vertical orientation located in posterior stroma. Why posterior stroma? Because posterior stroma is loosely packed with the what is called lamella. So observed when the level of edema is reached above the 5%, striae are thought to represent fluid separation of the predominantly vertical arranged collagen fiber in the posterior stroma. This is good picture to understand. So just understand posterior stroma is more looser. That's why edema you can see in the posterior stroma more easily or happens there. So fold means physical buckling of the posterior stromal layer in the response of the high level of edema. It's definitely striae low level edema, fold is high level edema. Observe endothelial mosaic and combination of depressed group and raised, or as a general area appear buckling. It's appear approximately 8% or more folds. Okay, his roughly that concept, but his it's more edema is needed. The stroma takes hazy, milky, and granular appearance when the edema reaches 15%. Okay, it's that. So C, this C has a haze. Okay, in B is a fold. Can you see that? In A, this is star. So these are things. Okay. Epithelial microcyst, which is very difficult to see. It's very important that you become very good with slit lamp. It appears as minute scattered gray opaque dots with focal illumination and transparent refractile inclusion with indirect retroillumination, and primarily represents a chronic stress metabolic stress and alter the cellular growth pattern caused by direct or indirect acidosis effect of hypoxia and hypercapnia. Hypercapnia means high volume of CO2, isn't it? So represent an extracellular accumulation of broken down cellular material trapped in the basal epithelial layer. So epithelial microcyst is a condition commonly seen not just in contact lens but many more cornea complications. So you must be cautious whether it's due to the contact lens or whether it's due to any disease related to cornea. Okay, so epithelial microcyst you can see here. Epithelial edema, it's so it should be noted that epithelial edema doesn't occur in response to hypoxic stress. So etiology is always osmotic stress. Okay, yeah. So endothelial blebs is black non-reflecting area observed in endothelial mosaic. So it can be observed in 10 minutes, as we have already discussed. Yes, endothelial blebs is a transient response because of local acidic pH shift, isn't it? An endothelial breach is simply individual endothelial cells and group organization has become swollen and bulged in the direction of ectodermal. It's important. Swollen and bulged in the direction of ectodermal. Okay. So this is the specular reflection method we have taken this picture. So another is H2O plus CO2 is carbonic acid, and then blebs is happening. See this is aqueous, and the cell shift bulges out towards aqueous. Okay. Endothelial polymegathism, the Greek word poly and megathos. So basically literally means many size, and etiology is same as endothelial blebs, but it is the chronic response. Endothelial blebs is transient response. So that's the difference. Okay. So polymegathism means, can you see in this second picture? Yes, cells larger, larger and larger, isn't it? When there is a large, there is small cells and large cells, so distributed like zigzag. So here moreover cells are moreover similar size, but here cells are very zigzag. One size is smaller, one another is higher, larger, another is smaller. Okay, so let's do summary. Any reduction in the amount of oxygen available to the metabolically active tissue can significantly alter physiological equivalent of the tissue itself, and the cornea is also no exception. It's always there. Cornea is no exception. So adequate oxygen is vital for metabolic process and structural integrity. Contact lens effectively occlude the cornea from surrounding environment oxygen, tear, and ocular secretion. It's very important. So contact lens prevent cornea from surrounding oxygen. That's why we need high decay contact lens material. Yes, yes. So there are a few numbers that I want you to understand. I want you to review it because I have taken it from first free version of icon. So in MCQs, these are very very important. Okay, so for successful contact lens wear, the lens fitted must supply the minimum level of oxygen cornea requires. Very important. At least you as an optometry student or as an optometrist must be cautious that there is adequate level of oxygen you are helping to pass in your patient's cornea. Okay, I think that's it for today. These are the references. Just go for the CT article, a lovely article. Obviously I'm a fan of Efron Complications. It's a great book. Yes, free version of ICL Model 1. And I think that's all from my side. Okay, these are the reference. Always remember my reference is very important. So, Vistantius.